Okay, so we continue with the part 2 of our problem. So from part 1, we just managed to find the total distance between the two lists by just adding the corresponding, the difference between the corresponding numbers. In this case, part 2 begins by saying that the analysis we conducted only confirmed what everyone feared. So the two lists of location IDs are indeed very different. Or are they? The historians can't agree on which group made the mistakes or how to read most of the chief's handwriting. But in the commotion, you notice an interesting detail. A lot of location IDs appear in both lists. Maybe the numbers aren't location IDs at all, but rather misinterpreted handwritings. This time, you'll need to figure out how exactly often each number from the left list appears in the right list. Calculate a total similarity score by adding up each number in the left list after multiplying it by the number of times that the number appears in the right list. So in this example, for example, we have the left list and the right list, and 3 appears. So here they give us the example. So the first number is 3. It appears in the right list 3 times, so the similarity score increases by 9. Then the second number in the left is 4. It appears in the right list once, so this would increase by 4 times 1. Then 2 is not in the right list, so the similarity score increases by 0, and so on and so forth. Then the total, what we are required to present is the total similarity score. Okay, so going back to our problem, previously we sorted the numbers and so on and so forth. In this case, we need to find how many times a given number in the left list appears in the right list. So perhaps this is going to be easier or harder dependingly. So depending on how we want to approach this, we could use the greedy method, where we would have to check how many times each number run a loop. Maybe that will be n squared, n times n, so n squared. Another way would be to maintain an array, a very large array, because we have really big numbers here. So we get a very large array and we keep track by just indexing. So that will be O1. Every time we want to check how often a number has appeared, that will be O1 in the list. Maybe that's what we should be doing. Let's see. So to do that, let's create a very big array. I think we can malloc. So looking in this, we don't know what the largest number is. Maybe we can just get it after sorting. That's looks like a very good idea. After sorting, let's get the largest number. Largest number is equal to, let's say, buff2, since that's the right side, ptr, and ptr buff2, or this is buff2 dot length -1. Okay, so then we shall create an array here. So we shall say, I don't like this because it's going to make us run through these two arrays twice. Of course, it's ON, but we could do this on the fly, right? Perhaps we don't have to do all this. Let's say, let's do this. Let's say this, the counter. We could do this byte-wise. Let's just take, so we shall have a count buffer. This buffer holds for each value. In other words, we're going to be indexing. So if we have this value, we have a very long buffer. So if this value appears, we take it as an index, and we just increment its position. So in the end, all positions will be having the numbers of values, or numbers of times values appeared in the array. So we will have this, and then let's keep the largest. Okay, so let's the largest become -1, I think, and if largest is less than numbers 1, then we can say largest is equal to numbers 1 plus 1. Let's do plus 1, and then we can say that buffer, numbers buffer, counter buffer is equal to realloc. Okay, that will be counters buffer, and the size is going to be largest times size of int. Okay, all right. And then we shall say, excuse me, and then we shall say this should be null in the beginning, otherwise we'll have a problem when we call realloc the first time, depending on the allocator, of course. So after reallocating this, we should make sure that this is zeroed, by the way. I think this time we should just calloc, since calloc returns zeroed memory. So, or in most cases, that's what is expected. Let us calloc number is count buffer, and this is largest, and this is size of int, and this is going to be int new, just in case. You never know. Let's first clear it out. New. Okay. New. Let's set it to 0, and this is largest times size of int. Okay, and after that, if the largest, sorry, if the counter buffer is null, is not null, then we need to copy whatever we had before. Copy. This is okay, now that largest has changed, I think we need to keep a temporary here. Okay. And so since temp largest starts out as alright, since it starts as a negative, we might be able to take care of this. I think maybe one check is enough, since if it's null, then this is also less than 0. Otherwise that should be okay. Okay. Then we can say we are copying to the new memory, and the old memory is counter buffer. And amount to copy will be largest, temp largest, size of int, right? Okay, and then we shall say that counter buffer is equal to new. Okay, and after that we can say largest, of course, has been changed, and then we can say Therefore we need to update this counter buffer numbers 1 plus plus. Right. Okay, so this way we have managed to keep track of this. We have the largest value, will be the largest index that we can have of the right list, and then after that we also make sure that we have, so we are using indexing anyway. So next, let's try to get the distance, the similarity score. Okay, so counter buffer, and then the first buffer, the left one. Okay, we also need the largest, what did we call it? Largest value on the right. So let's call it largest right. Okay, so we shall say that the similarity score equal to, similarity score is initialized to 0. Then we can also say that let's keep an index here that's 0. So while the index is less than buff2, buff1 length, that if buff1 ptr at index is less, is it less? Should we keep less or less or equal? Less or equal to the largest right. Then we should have similarity score plus or equal to buff this value index timers counter buffer at this value itself. So ptr index. Okay. So how much of this did we count in the right side? If it doesn't exist, as we saw in our example, so in this example, cases like 2, so at index 2 in our counter buffer we will have 0. At index 3 in our counter buffer we will have 3. At index 4 we will have 1 since it appears once. At index 1 we also have 0 since 1 is not here, right? So if we continue adding everything, we should end up with a similarity score. Okay, so we'll get the value times the counted number of times that it appears in the right side, and let us return the similarity score. Okay, let's create another variable. Similarity score, and we can say similarity score is equal to get similarity score. It requires the counter buffer, and we can say, okay, this requires a counter buffer, buff1 and largest. Let's see whether this is going to help us. Let's also print similarity score to be our similarity score. Okay, let's compile and run. right, so this is our similarity score. Let's see whether it's correct. All right, so this works. Again, that marks that's enough for day one. We can continue again for day two. Thanks very much for watching. If you like this video, please like and subscribe. Thank you very much. See you another time.